Welcome back. Please do the attendance. Oh, thank you, Shafna. Okay, remaining participants, there are a few more participants that have not answered the poll questions. Could you please answer? I am going to close the poll. Okay, it looks like a lot of you have not um, used IBM Cloud, do not have IBM Cloud account or ran a quantum code on a real QPU. So that's fine. So let's see. Um, oops. What we're going to do is exactly um, uh, create these things, and I'm going to share. And I would like for you to follow me with this. So you should be able to see my screen now, right? Are you able to see the screen, guys? Huh? Okay. So let's go through this thing, right? So what you need to do is first open Google Colab. So let me share it a different way. Maybe like this. Okay. Let's open Google Colab. And also IBM. So let's follow the instructions here. So these instructions will also be mailed to you later by Dr. Gargi. So you can follow them. So open Colab and install your Qiskit, right? Go to colab.research.google.com. Are you doing that with me? Go to this link here, colab.research.google.com. Okay, so and create a new file, a new notebook, and let's go back here and install this. So every time you run on Google Colab, you may have to restart the session, which is fine. But if you want to run it on your local computer, that's fine too. But I just use Google Colab more, so I find it easier to work on the Colab. Is anyone facing any difficulties installing it? Is everyone able to install it? Are you with me? Please reply yes in the chat if you have if you are able to run the first instruction of installing that. I would recommend more than 2.0 because some of the codes in Qiskit have changed after IBM migrated to the cloud. So if you have an older version, then maybe I was facing some issues. So that's why I intentionally put Qiskit greater than 2. So such issues don't appear. I hope that answers your question, Saptagiri. Yeah. So it is better if you put more than 2.0 because they after they migrated to cloud. Before there was no issue, but after migrating to cloud, there's some issues. Okay, is anybody facing any issue with the first part? If not, was the document mailed to us? No, it is on the screen. Can you not see it on the screen? Or I can put it in the chat box on Zoom so everybody can, you can download it if you want to see that. Oh, I see. You're not able to click on the link because I'm just sharing the screen. How dumb of me. Hmm. नहीं मैंने भेज दिया है इसको chat में हाँ. So you should be able to see it in the chat. Sorry guys, I was being dumb. So you can download that from the chat. Are you guys able to see it in the chat? Yeah. Yes. Okay. So please download that. Go to Google Colab and then um, open some new notebook and install. So after you run the first command in Google Colab, you should be able to see this. I hope you are seeing that. And so for the next part, just cut copy paste the code, but don't run it, because we have to first create the IBM account for the second part of the code that I just highlighted on the screen right now. Just copy paste it in your as a new code cell, but do not run it yet. We have to replace this API token and the CRN here after you create an IBM account. So do not run it, just paste it. So it will be great if you guys reply yes after you have done the first part, and then paste the second part. And then if you do not have IBM account, please go to this part. First part done. Then just paste the accessing QPU part in the second one. Do not run it. Go to step 3. Open a web browser with quantum.ibm.com. Okay, I think I need a fake ID now to sign up for this. Huh? But I need a new email too. That's okay. I guess. Okay, if the second part is done, please just go to quantum.ibm.com and you can see here, create an account to run on real quantum computers for free. And then you can sign up there with some email. At Gmail. What is the no, this is I hope you guys are. If you have an account already, that's you can proceed to the next step. But I think most of the people do not have an account. So please, I guess uh, once you have created the IBM account, please let me know if you have finished and you see the IBM platform dashboard. Says it's incorrect. Okay. Uh, I don't see any available instances with my account on my dashboard. Okay, Saptagiri, just give me a second. I'll get back to you. Just let me. I need my password to. I don't remember my password. Okay, I hope. Okay. Yes, Mahesh, what you're seeing is good. Is everyone able to see like what Mahesh is seeing? So you should be able to see the IBM uh, home platform. Created an account. So Saptagiri, if you don't have any instances, maybe you used all the time. Maybe you need to use a new email ID to create a new account. So you should be able to create an API key here and instances here. And then, so you can sort of create an API key here, right? And give it some name. You're able to see the API key, just give it whatever name, just hello world, create, and whatever you get, copy it, then go back to Colab and see here, it says paste your API token here, paste it. So that's how your API token should look like. Yeah, I think creating API key and instance is different. So I'm not sure why, maybe, but don't say any instances. May I need, yes, you need to migrate to cloud. You have to migrate to cloud. That's what I was saying. So after you have pasted the, yes, if you have created before July, I do not know when the cloud started, but for now you need a cloud account. So I recommend that you create maybe with a different mail ID probably. That may be easier. But is everyone able to create an API key and pasted the key? Please reply in the chat if you have done so. And if you want to access this API key later, you can see view all, right? But when you go to view all and you want to copy the API key, please make sure that you don't copy it properly. So when you go and see all the API keys, like for example, if I look at my API key that I just created, it will show you like, so here, it will give you API key. So you have to remove that. So you see, it gives you like this API key, which you have to remove, right? So be careful about that. And then you can create an instance here under instances. Is everybody able to see the instances? And you can create an instance, copy the CRN from the instance. Please let me know if you're able to create an instance and copy it. See it's IIT Roorkee. That was my student email ID. So that's why it's showing as IIT Roorkee. So no, I'm just telling them that's okay. In case somebody. Is everybody able to paste the CRN? Can you please reply in the chat? I see. Okay. I see a couple of people saying yes to CRN. Okay. So if you have pasted CRN, please run it and see, paste your CRN. I want to paste my CRN. So your CRN should start with CRN in the beginning. So you should be able to see that and then run it, and hopefully it runs. Right? So let's see. And then you should see stuff like how I'm saying that it is connected to IBM Quantum and found two backends. Once you pasted API and the instance, please confirm that you have done that. So if you don't want to forget, if you don't want to keep going to your IBM account every time, on Google Colab, you see this key, which says is secrets. So you can also add a new secret, and you can put here whatever, IBM API key, and then IBM API, and then you can paste the value here, and then granted the notebook access, so you can just don't have to go to your IBM account again, right? So you can directly call it from your notebook. But for now, we will just run it like this. So I hope everybody is able to run this part. Is anybody having difficulty? Okay, then let's go back to the PDF file, right? And then let us list the available backends. So we want to see which quantum computers are actually available. So we will get both simulators and real QPUs. So just paste that and see. So I see that IBM Brisbane, which is a 127 qubit computer, and IBM Torino, which is a 133 qubit computer, they are available. Is everybody? Those are the ones that are probably you are going to see as well, based on the geographic region. You may see a little bit difference, but okay. So you can either see this way, or you can also see the least busy one. So so that for seeing the least busy one, you can look at the next part of the code, right? Backend. So we want to look at the least busy one, right? So we want to do it on the least busy one. So let's see. Okay, IBM Torino is least busy. So we can use IBM Torino. Is everybody following? Is there anyone who is not able to follow? Please reply if you are not able to follow.
Sir,
I got IBM input value error at step 2. So then that means that you have not pasted your API token or your instance properly. Mahesh, please paste that in the within quotes. Did you paste it within quotes? Did you also paste the API token? Okay, then I'm not sure why you are getting an error. Yes, after pasting API and CRN, please run it. Shafna, after pasting API and CRN, please run it. And then you should see this. Pratima, I don't have and make an account. There is some error. So you are not able to make an account? Is that what you're saying, Pratima? Try to use, if you're trying to use sometimes if you're trying to use like your institution email, it shows problem. So please use, if you have a gmail.com or simple email like that. If you have, like, for example, iatd.ac.in or like .edu, then it is showing some problems. So if you have just a Gmail, use a Gmail, simple Gmail account to simple Gmail isn't working either. Then I'm not sure. Anuradha, done the step now. Okay. Then I am not sure why that is not working. Is anyone else facing that problem? Is anyone else unable to create the account? Looks like your name isn't quite right. What does that mean? So it's saying that dot is an invalid character. So maybe you need to have some email without that, or I don't know. I'm not sure what that means. How can it tell you that your name is not quite right? It is funny. Um, I'm not sure,
sir,
Anuradha, what is happening.
sir,
Okay,
Anuradha
okay,
can
good,
try
Saptagiri.
going back
Uh,
and
so maybe if you have another email, Anuradha, maybe try.
hello, sir.
Yeah,
Am I
so
audible?
Saptagiri says that's a dot in your email ID that's causing the problem. And Shubhanshu has a suggestion that you can also sign up directly uh, from Gmail. Okay, Satvik, once you have created the account, please create API token as described in section 3.2, right? So once you have created the account, go to API key, create API key, and paste API key in the second cell, and then create an instance, copy the CRN, paste it here, and run this cell. Okay, that's great. So sign up from directly from Google itself. So please try that. And then please run the second cell, and then run the third and fourth cells as shown here. I will wait here until all of you confirm that you're able to run these. Anyone else having problems? So maybe I think it is better to go by roll call. Okay, Abhilash, were you able to create and run the cells? Okay, no response from Abhilash. Well, let's move on to next. Okay. Yes. Ipsa Tripathi, were you able to do that?
Yes, sir. Yes, sir.
I guess she said yes. I mean, you don't have to run it in separate cells, Shafna. You can run it in the same cell also if you want. Mahesh, you were able to do that. Murari, were you able to finish everything?
Yes, sir.
Up to
Able to
cell
follow.
4?
Hello. Yeah, able to follow, sir.
Pratima was having issues. Pratima, are your issues resolved? Okay. Priyanka, were you able to run it? Priyanshu, how about you? Rohit. Okay, Pratima, no problem. Please see. Okay. Okay. Rohit. Saptagiri, I think you were able to do it. Satvik. Okay, great. I think Shafna ran it. Shivam, I think he ran it. Shubhanshu was able to do. Tejaswini, Tarlapalli. Tejaswini, were you able to run it?
Yes, I am able to run it.
Vedveer, were you able to run it? Any issues? Okay, Vedveer is able to run it. That's great. Tejaswini, were you able to run it?
Hello, yes. Yes, I was able to run it.
Veer Roy, I think I saw yes. Okay. Okay, didn't hear back from. Okay, Tejaswini also said yes. Okay, Pratima, were you able to? Okay, 7 steps done. That's great. So if you're done, if you're comfortable reading with stuff, then you can proceed to the next cells. Pratima, were you able to do that? No. Okay. I'm not sure. Maybe you try signing up directly from Google. Hopefully, you will be able to do that. Okay. Anuradha is trying with Google and it's not happening. So I think Anuradha, it is due to the dot in your email. So maybe can you send me the link again? I mean, it is in the document. Okay, that's great. PDF. Okay, it is in the chat. So if you scroll up to the chat, it is there up in the chat. I will put it again. That's fine. To Pratima. I sent it to you, Pratima. Okay, if you're done with that, then let's build a simple circuit. So here, copy 5th part, right? And then so here, when we write from Qiskit import quantum circuit, you can name it any variable. I just called it QC. So this first part is how many qubits you are creating. The second one is how many classical bits you are creating. So if you are going to measure, then you need a classical bit. And your qubits and classical bits are ordered or numbered from 0. So if you create one qubit, then that is accessed by accessing 0. That is the 0th qubit is the array is like starting from 0 index. So this is measure the 0th index qubit and store it in 0th index classical bit. So if you run it, you should be able to see like this. This means create 1 qubit. So you see 1 qubit and you have a classical bit associated with it, and apply X gate, right, which is a NOT gate. And then after applying the X gate, you measure it, right? So once you measure it, you will get whatever answer and you will store that in the 0th qubit. That's what this is basically telling you. Okay. Anyone seeing problems with this? Then what we are going to do is we are going to run this on a simulator. That is, this is not a real quantum computer, but a simulator. So the simulators come from this Qiskit AER. So that's why we installed this Qiskit AER. This is related to the simulator. So if you just install Qiskit, simulator may not work. So make sure that you have installed Qiskit AER. And then from that Qiskit AER, we access something called primitives. And whenever we are running it, we import a sampler to run our job. And here the sampler is AER sampler, that is the simulator. It is not a real quantum computer. And so we are just assigning that our sampler is AER sampler, that is a simulator. And our job is run this QC. So whenever after you have created the circuit, you put that circuit here, and how many ever shots you want, you can put that here, 2000 shots, for example. And then the way you access the results of your job depends upon how many variables you have in your quantum circuit. Here we have one variable and one classical bit. So you're going to get, in simulation, you can directly access the probabilities. So you multiply the probability by the number of runs to get to see the number of counts, or you can just print probabilities itself. So if you just want to print probabilities, you can just print probabilities, right? So I'm going to run this. Ooh, counts in, I got some error. Print, okay. Just a bracket missing. That's simple enough. Okay, so every time I start with a 0, because when we initialize the circuit to 0, and then I apply a NOT gate and it becomes 1. So when I measure it, I get 1. So in the simulator, 2000 times, every single time I'm getting 1. Is everyone with me there? Any questions? Okay, now let me stop and ask you, what would you expect from ensemble interpretation? Do you think we should get 1 2000 times? Okay, no. Tejaswini says no. That's right. Let's check it out. All right. So the simulator is lying to you. The simulator is showing that it is 2000 times. If that is the case, right, then let's check it out. So let's go back and run on a real QPU, right? So the QPU code looks little bit longer because this is because of the way you access the results. I tried to access the results the same way, but it was creating some issues. So I just went ahead with unpacking the bit array. So you don't have to worry about it. Until this part, it is exactly the same. So you see here that we are doing something called transpile. What transpile means is that whatever we have created, the quantum circuit, our quantum circuit is this QC. I've created this. This means it has to tell that this X gate, recall in the last lecture, I told you that this X gate has to be applied for a certain time based on the Rabi oscillations. And then you get this pi/2 rotation, whatever that is, right? That is, you have a transmon and you have to apply certain pulse, right? So it is transpiling the instructions to tell what pulses it has to apply, right? based on our circuit QC. So it is QC, backend is not the simulator. So previously our backend was a simulator, but now we are going to use the real backend, which is, recall that here we said backend, pick the least busy one, right? But you can also directly say IBM Torino or IBM Brisbane, whichever one you want. But usually I just pick the least busy one. So we already assigned the backend. So we put that, and we'll go into optimization level later. Now we are going to run on simulators. We run using AER sampler. So right now, the Qiskit IBM has, after migrating to cloud, we are using sampler V2. So you can download that as sampler. So we are going to use sampler V2 for the real quantum computer. So we are going to run it with sampler V2, but use the mode as backend. We are not doing the simulator. So it's actually running it on IBM Torino, the actual quantum computer, right? And this is TQC, not QC, because you have to transpile. We transpiled that. And because we transpiled that, the result we get, we have to access it a little bit different way, because we're getting bytes instead of bits, like in the simulator. So we have to unpack bytes into bits and then take the last bit as your result. So you don't have to worry about this part if you don't understand that right now. But until this part, it's exactly the same, except your sampler is running it on a real quantum computer. Okay, let's see what happens. So there, your job ID. So if you go back to your quantum platform, you should see that your job ID is running there. And see here, I got one only 1730 times. 270 times I got 0. Right? Is everybody able to see that? Did everybody run that and see that? Any questions? So this could not, it could be due to ensemble interpretation, but it could also be due to, because, yeah, please type your numbers there. Dr. Gargi is asking you to type whatever probabilities you got here. Okay. Okay, that's great. 286, 1714. Okay, with 2000 shots, 288. Okay. So this could be due to the gate error, right? That is, our gate itself is not functioning properly. That is, our gate itself is 13.5 times % of the time, our gate itself is not functioning properly, or this belongs to ensemble interpretation, right? There is a way to check that, right? You can check the gate errors and then confirm that this is not really within the gate error. Okay, Mahesh, Shivam. Okay, but we will not do that today. We'll do that later. Okay, Shubhanshu, Vedveer, Shafna, Veer Roy, Satvik. Did you guys get it? Priyanshu, Priyanka. Were you guys able to see that it's not giving 100% of the time 1730? Okay. So the question is, how do we rule out that this is not due to the gate error itself? That is, I could say the gate doesn't function well 13.5% of the time. How could I rule that out? Any? Okay. So let's see. Let's see what would happen, right? If we now apply the NOT gate twice, right? So I'm going to go up to the 5th cell where I have QC.x0, right? I'm going to apply it twice. I don't know if it will work. I'm just going to try it. I'm going to apply NOT and NOT, right? Now let's see what happens. So I'm getting 0 2000 times in primitive circuit. Then let's see what happens. So if it is a gate error, would I get a higher error or a lower error? we should get a higher error, right? Right? So let's try it. But I got a lower error, right? Or similar error, I would say, 158, 18, 12. So can this be gate error? Were you guys able to do that? Apply the NOT gate twice, got lower error. I mean, I don't know whether we can say lower or higher, but similar, some error we got. But it is definitely not much higher, not compounded. Let us run it again back to 1. I'm going to try it again to see if it is going to change. But the thing is, see how fake the simulator is. It is so fake. I sound like Trump now. But let's see. Okay. See, now again I got 319. Now I got higher error. And then you can go back to your IBM quantum platform and you can see under instances how much time is remaining. So it doesn't take much time, like it's running only like for 5-10 seconds, right? Applied NOT gate twice and you got 0.078. Okay. Okay. But we ran it thrice and it's coming back to the same error.
Non-gate error.
Then it's not gate error. Yeah. Okay. Is everyone comfortable with that right now? That everybody is able to see that you are getting in simulator all the time the same result, but not in real quantum computer. I hope all the time we spent last week makes sense to you now. Yeah? Okay. Yes. Okay, then let's move on to this thing and let us try different shots and see if there is any changes in different shots, which you can do later by yourself. But for now, we'll try to do exercise 1, right? We will run a Hadamard gate. As we discussed in the morning's lecture, a Hadamard gate takes, if you start with a 0, then it goes into 0 plus 1 superposition state, right? So you go back to the top cell where we created the quantum circuit, and then instead of X gate, we want Hadamard gate, right? Excuse me. We use H, and then I run it, and you should be able to see the Hadamard gate and the measurement. Is everyone able to do that? So Hadamard gate puts it into superposition. So I should get pretty much 50%, 50% when I run it on a simulator. Why is the simulator is erroring now? Because the Hadamard gate itself is preparing differently. It is not preparing the same one, right? So it is in the preparation, right? So it is because of the Hadamard gate. It is simulating the Hadamard gate, not just one gate. But it's still, you see it is supposed to be equal, but it is doing that because of the way we're running. So you can change the shots, and if you increase the shots, this is like coin toss. If you do 2000 times coin toss, you don't exactly get 450, 500, 500 or whatever. You get little bit difference. That is how you get. So that's what the simulator is doing. Suppose if I do, let us say, instead of 2000 shots, I'm answering Saptagiri's question. So if I run 10,000 shots, right? Okay, I have to change this to 10,000. So you see the difference decreases. Saptagiri, are you able to see that if you, it is due to the number of shots. Ideally, you need to go to infinite shots. So let's go back to 2000. And then let's see, make sure you're able to run. Yeah, it generates random numbers, that's right. So now let's run this part and see what it shows. 0.549 and 0.451. Right now you can change for this part, you can change the number of shots and compare, for yourself. We are not going to do that right now, but change the numbers and try to compare for yourself how that changes with the number of shots. Like for example, if you run instead of 2000 shots, if you run like 5000 shots or whatever number of shots, how that this probability change, right? If I were to make it only like, let's say 100 shots, what would you expect? Would you expect the things to be very different? Saptagiri, why are you getting probability more than 1.0? I don't know whether that is right. Multiplying it by the wrong number somewhere, yeah. But yeah. So if that was the simulator or the, yeah, so but if you change the shots, it should automatically change in the experimental one, the probabilities. Okay, that's great, Shafna. But I defined in the experiment one, I defined shots, so it's not summing up to 1 somehow. N0, there is, okay, so let's remove this part. Yeah. Yeah, so in that shots, I had like whatever, I was trying to get it another way, but if you just change here, this part, I highlighted it on the screen, just change that as well, then it should work. So you see, I changed to 100 shots and then I have 64% and 36%. Right, okay. I hope everybody is able to do that. Is there anyone who is not able to run it on a real quantum processing unit? Why is the probability more close to equal on reducing the number of shots? Shouldn't that be opposite? No, it is not more close to equal. It is different. It is 64-36. Okay. Now the probabilities look better. Yeah, I mean it depends. It's not the same. That's the thing with the real quantum computer. That you get what you get. But in the simulator you get the same always. Now the next thing I want to do is so you guys can go back to the PDF and do this exercise of running it for multiple times and see what you see the difference between these two things. I want to go to second exercise where you create a 2-qubit state, right? And you can create a Bell state from a 2-qubit state. So when you create a 2-qubit state, remember that the rightmost qubit is the 0th qubit. So if we usually write our qubit when we write by hand, if we write as 0, 1, on Qiskit that will look as 1, 0. Please see Dr. Gagi's comment that when after our lecture you can play with it more and make plot for step number 8. right? And share with us. Please do not forget, we will also send an email, right? So to create a 2-qubit state, right, you need to create 2 qubits, right? And we want to measure 2 qubits. So now when you do 2 qubits, you can apply the gate either on the first qubit or on the second qubit. Okay, so let's see. I'm just going to create 2 qubits and 2 classical bits, and I'm going to apply Hadamard gate only on the 0th qubit, and I'm going to measure the 0th qubit and store it in 0th bit, and measure the first qubit and store it in the first qubit. I hope this works. Yeah. So you see that I'm applying Hadamard gate only on the 0th qubit. And then measuring 0th qubit, but also measuring okay, it is showing measuring the 0th qubit again. So measuring the 0th, okay. Let's see. I have to do it this way. Yes. So applying Hadamard gate and measuring the first qubit and just measuring the second qubit. Is everyone able to see that? So you can run now with the simulator. I hope this works. Yeah. So then you get whatever 0 and 1. So that's how you create a 2-qubit state. But our qubit state is not the state that we want. What we want to create is we want to create a Bell state, right? And we want to put it into this state. So try to yes, Mahesh. So what you should do is not 0, 0. So the first part here is the qubits you want to measure. So you measure 0th and 1 qubit, and this is 0, 1. Store them in 0 and 1 qubit. If you put 0, 0, that means measure 0, 0 again. Okay. And you can do the same thing here. You can also apply Hadamard gate on the first qubit if you want. So Hadamard gate and measure. Right. But see that these are not entangled. These are just 2 qubits. We did not entangle them. What we want to do is we want to create the Bell state. So please go back to the lecture notes, which we haven't shared the lecture notes, which Dr. Gargi will share. So this is the lecture notes we had in the morning. You should be able to see it on the screen. So I showed you the gates there. So this is the Hadamard gate, right? And we have ISWAP gate. Yes, that's right, Mahesh. So in the first lecture, I thought, yeah. So see here, ISWAP gate, square root of ISWAP gate, you can get the Bell state. So figure out how to run this. I'm not going to give you the solution. In addition to ISWAP, there's another way also to run it. So figure out how to run that, so that you have enough information to figure it out. And you can ask GPT or you can ask Gemini or whatever you want to do. Figure out how to apply the ISWAP gate and create a Bell state, right? And what we will do is we will try to make some measurements on the Bell state and the singlet state. So I want to create 5 plus this state and psi minus state, 2 states. Create 2 states, and we will measure with simulator and QPU and find the differences. So we will stop here for today's lecture because I want you to spend time to do exercise 2 and exercise 3 and see what results you get. So tomorrow, when we come back, please have these results ready because that will be very important for what we are going to do tomorrow. Tomorrow we are going to do EPR paradox and Bell's inequality. Dr. Gargi will go through that. So for you to understand that, please run these and have your results. And please try to send us the results if you can before tomorrow's lecture. And we will share the solutions with you after tomorrow in the lecture tomorrow. Are there any questions? Okay. So Subhanshu, the 10 minutes time is what you are getting to run for free. Yeah. So every time you run, the time is going to decrease. So you can run on a quantum computer, you can run for free for 10 minutes. That's it. About 10 minutes, you got to pay. Right? So that's the free time that IBM is giving. I showed that already. Yeah. But note that it doesn't take much time to run one circuit. So it takes like 1 second, 3 seconds. So we ran so many things, but it's still like 9 minutes, 34 seconds is remaining. And remember, we ran like 2,000, 4,000 shots. So you can actually do a lot with 10 minutes. The only thing I would say is if you are using GPT to code, GPT codes thinking that you have paid access. So tell GPT you don't have paid access. So it is not supposed to use sessions. So if you use GPT, tell it that you cannot use sessions because sessions are only possible in paid, not in open access. So we're using open access. Satvik, I'm not sure why you are getting an error after pasting CRN. I do not know. So maybe, try to repeat again, try to go from scratch and see. Placeholder was not removed. Okay. So, was the placeholder removed, Mahesh? Sorry, not Mahesh. Satvik. Mahesh says placeholder was not removed. So, so please, you have to remove the placeholder. Paste your CRN here. It's just a placeholder. So remove that. Okay. Thank you, Satvik. Okay, guys, I think I hope you're able to see and I hope you enjoyed running it on the real QPU and see how simulator is different from real QPU. What we are going to talk about tomorrow is about Bell's inequality, entanglement, and I think there was a question on entanglement from Subhanshu. So we will see that tomorrow. You can actually simulate that on the quantum computer. So if there are no questions, we will stop the lecture here. And please do exercises 2 and 3 before the lecture tomorrow. Thank you. Okay, thank you, guys.